Question 50. An adiabatic pump, so this is adiabatic pump, no heat loss, of efficiency 40%, so this has an efficiency of 40%, is used to increase the water pressure from 200 kilopascal to, so from here 200 kilopascal to 600 kilopascals. Okay. The flow rate of water is 600 liters per minute. So that's what it is. The specific heat of water is 4.2. We know that for water, CP is always 4.2 kilojoule per kilogram degree Celsius. And of course, density is equal to 1000 kilogram per meter cube. The maximum temperature rise. So we have to find what will be the maximum temperature rise between the two. So between here and here, what will be the maximum temperature? That is delta T. Okay. So first we have to find out how much power we have to put in. Let's call that as PB. How much power we have to put in to increase the head of the water from 200 kilopascal, pressure of the water from 200 kilopascal to 600 kilopascals. And after that, we'll see that 40% of that would be 40% of that would be used to increase the head of the water, whereas 60% would go for increasing the temperature of the fluid between these two. So first, let's do the calculation. We know the head is defined as P over rho at any particular point gz plus alpha v squared. This is the average velocity, this one. Now, if we take the points A and B, where A is this point inlet and B is my outlet, we can say, assume that the elevation ZA is approximately equal to ZB, and of course we also assume that the velocity at A is the same as the velocity of B, assuming the pipe diameter to remain the same. The flow rate of course remains constant. So therefore, delta H would be basically PB minus PA. The difference in head would be the pressure difference divided by the density, right? We're getting this one from here. Okay. Next is how much is the power input to the system or to the pump. So PB we know is going to be equal to PF of the fluid divided by the efficiency of the pump, which is equal to, we know, m dot delta H over, so this is equal to m dot delta H over eta. So this is PF is equal to m dot delta H. That means the difference in head. So we can just write this one as m dot. This is going to be equal to PB minus PA divided by rho and eta. So that's a power, total amount of power we are putting into the fluid through the pump. Now out of that power, 40% will go to increase the head of water, and rest for 60% of course will not be utilized because it has an efficiency of only 40%. That will go to increase the water temperature. Okay, and that of course is going to be equal to m dot Cp, that's the flow rate of water, the specific heat of water, times delta T. That means this is Tb minus Ta. That means the increase in water temperature. So if we can equate these two, we can say 0.6 times of Pb, that means 60% of this one, that would be equal to, let's call that 0.6 times m dot times Pb minus Pa over rho eta, and that will be equal to rise in temperature of the fluid, that means water, that will be equal to m dot Cp TB minus TA. That means rise in temperature. This is my rise in temperature. So these two m dot really cancels out. So the flow rate of water really does not matter. We know the values of PB and PA and everything here. We know the values of PB, PA, we know the values of rho, we know the value of eta, we know the value of CP. So automatically the value of TB minus TA, that means the rise in temperature, can be calculated, and that comes to be equal to 0.142 degrees Celsius. So this is our answer. Detailed calculation, of course, are shown next to this particular.